Hello everyone. The title of this video is Solve Polynomial Equations by Factoring. So in this video, we go over many examples where we're given an equation, right, specifically a polynomial equation, and asked to solve it by factoring. And I'll discuss how we're doing this. Now I am going to assume that you know how to factor polynomials. Right? I'm not going to go into very much detail as to how I factored certain polynomials because I've already made videos prior to this. I'm hoping you've seen, or I'm hoping you've read in your textbooks how to go about factoring polynomials. Alright, so if I factor something too quickly for you, perhaps you need to refresh your memory on how to go over the methods of factoring earlier in the chapter 6 that we're going over here. Because every single exercise I'm going to do in this video is taken from a free online textbook at openstacks.org in their intermediate algebra 2nd edition text. And I'm specifically in section 6.5 titled Polynomial Equations. And I'm going to be doing the exercises with the heading Solve Quadratic Equations by Factoring. Now quadratic means second degree, right? Meaning the highest power you see is the second power on any variable. But I did notice that later on in the exercises, starting at like 307, you see third powers, right? And these are not quadratic, they're cubic. So that's why I changed my title to Solve Polynomial Equations by Factoring, right? Quadratic and cubic. But the highest I think they get here is cubic. So yeah, so I'm gonna be working on exercises 283 all the way down to 312. Example 1 in my video will be number 283, example 2 will be 284, etc. Right, all the way down to, I think, example 30 will be number 312. And I will have timestamps for each example in the description of the video, so you can skip around to see specific ones if you wish. So for instance, if you wanted to see example 28, exercise 310, you'd have to count down, say, hey, that's example 28, and then click on the timestamp for example 28, and you'll see me starting number 310. Alright? And as I try to say every video, when I start a new problem, when I start a new example, pause the video and try to work on it yourself. Try to see if you can do it on your own. Because you're not going to learn anything if you're just watching me do it and not doing anything yourself. Alright, so try working on your own, figuring it out on your own first, and then maybe watch me do it and compare your work to my work and see how you're doing. Alright? Okay, so let's bring it up. Alright, this is exercise 283. I'll call it again example 1. So yeah, we're solving all these equations, these polynomial equations, by factoring. Alright, so how do we do this? First, I want to get a simplified polynomial. And by simplified, I mean no parentheses, like terms are combined. I want a simplified polynomial on one side of the equal sign equals 0 on the other side. So basically I'm taking everything to one side and simplifying that expression and making sure there's nothing on the other side. Then, whatever this simplified polynomial looks like, I'm then going to factor that polynomial completely. And as I said at the top of the video, I am not going to go into too much detail all the methods for factoring I'm using. Right? I'm just going to tell you what I'm doing really quickly and then write the factored form of the polynomial. Because I am assuming here that you have already done the methods of factoring and worked on exercises and practice and read and noted and all that junk. So I'm going to have a completely factored polynomial again, equal to 0. And then we're going to solve using what's called the zero product property. And again, just like with the factoring, I'm going to assume you know what this is, as I've put out a previous video where I talked about using the zero product property. I'll state it again really quickly right here. The zero product property basically is if you have a product, and here I have a product with 2 factors. It could be a product with 3 factors, 4 factors. But if you have a product equal to 0, right, and only 0, this only works for 0, then at least one of the factors is 0. So either A is 0 or B is 0. Or they could both be 0, but at least one of the factors of the product is 0. Right? So you're going to use this and then solve these separate equations and then check your solutions back in the original. Okay, so let's perform these steps, and I'm going to perform these same steps over and over and over again. All right, so number 1, we have 5a squared minus 26a equals 24. And I want to solve for a, right? Find the values I can replace the variable with to make this a true statement. All right, well, I have a polynomial on one side that's simplified, sure, but I have 24 on the other side. And again, I want this. Right, I want to start off looking like this. Right, a simplified polynomial on one side and 0 on the other. So I'm going to need to subtract 24. Right? I don't need a different marker for that. So I'll subtract 24, and it gives me 5a squared minus 26a minus 24, right? Minus 24 equals 0. Now I have the first part, totally simplified polynomial, and and you're going to probably do this too. I want to write it in descending order. Highest powered term, a squared, next highest powered term, a to the first, and then the constant term. Okay, then we've got a trinomial here, 3 terms. There is no greatest common factor. Right. So I'll use what's called the AC method. Again, I'm not going to go into all the details, just take the lead coefficient times the constant term, 5 times negative 24. So that's negative 120. Right? And then I would like to think of a pair of factors of negative 120 that have a sum of b, a sum of the linear coefficient negative 26. And those factors, again, you might have to play around with that, but are negative 30 and positive 4. Right? Those multiply to be negative 120, and they add to be negative 26. All right, then to factor this by grouping, I'm going to rewrite it as 5a squared, and then rewrite the middle term using these two numbers as minus 30a plus 4a. Right? Isn't that the same as negative 26a? Right? And then minus 24, and I still have equals 0 here. And then we factor by grouping. All right, I put the first 2 terms in a group, plus put the second 2 terms in a group. And we factor each group and then factor the whole thing. First half, first group, they have a common factor of 5a. So that's 5a times, and then a minus 6, plus the second group have a common factor of 4 times a minus 6, still got the equal 0, and then looking at the whole thing, both these terms have a factor of a minus 6. So I've got a minus 6, And when I pull out a minus 6, the other factor would be 5a plus 4. And this is equal to 0. Now I'm not done yet. Right? All I've done is the second part. Right, I got a simplified polynomial on one side, 0 on the other, right here. Then I have finally factored the polynomial completely. Now I'm going to make this a little quicker in future examples, but I factored this to a minus 6 times 5a plus 4. And you can double check, FOIL, take a minus 6 times 5a plus 4, you'll get 5a squared minus 26a minus 24. Now comes the zero product property part. Because here I have what I want when I'm applying the zero product property. Right, I've got on the left side here, I've got a product of two factors. Right? And it doesn't have to be two factors, it could be 3 factors, 4 factors, but for the most part, we're going to be seeing 2 factors. I've got a product equal to 0. Right? And again, it's got to be 0 on the other side in order to apply this zero product property. Okay, so by the zero product property, either the first factor, a minus 6 is equal to 0, or the next factor, another factor, 5a plus 4 is equal to 0. And then once you've separated the factors like this into 2 separate equations, you're going to solve those. Solve each of these separately for a, and then of course check your solutions in the end. Now the first one's simple, right? Just add 6. We'd have a equals 6, or, and then this second equation, 5a plus 4 equals 0, I would subtract 4, divide by 5, we have a equals negative 4/5. And then of course, once we've solved, check your solutions. And you always check your solutions back in the original equation. Now, you could use a calculator or something, but when a is 6, 6 squared is 36. 5 times 36 is 180. 26 times 6 is 156. And 180 minus 156 is indeed 24. So this works. And I'll leave it to you for negative 4/5, but it also works. And I'll tell you this right now. If you do everything properly for a polynomial equation, if you perform all these steps perfectly correctly and you realize that, your solutions should be good. But still, it doesn't hurt to check. Right? You should actually always check. I'm just not here because I'm making a video. I don't want it to run too terribly long. Alright. So sometimes you might see this written as a solution set. I'm only going to do it for this first example. So the solution set for this equation contains the numbers 6 and negative 4/5. Right? So you might see that as well, where the solutions are written in some set. But from here on out, though, I'm just gonna circle the numbers that actually work. I'm gonna circle the solutions. Okay, so that was number 1, and every one of the 30 examples I'm gonna do in this video, I'm doing the exact same way, same steps and everything. All right, so example 2, solving for b. All right, this is 4b squared plus 7b equals negative 3. First step, get a simplified polynomial on one side, 0 on the other. So I'm going to be adding 3 here. So we have 4b squared plus 7b and then plus 3 equals 0. And now I have another trinomial, and again you can use that AC method that I used in the first one. Yeah, so I'll just write I'm just going to skip ahead to what the factors are. All right, so I'm going to break this up into a product. We'd have 4b, 1b, that'll make 4b squared. Then plus 1 over here, plus 3 over here. Right? 4b plus 3 times b plus 1 is the factorization of 4b squared plus 7b plus 3. So you can do that through guessing and checking, or that AC method, as I did earlier. Okay, and again, you can double check your factoring by multiplying. This would be 4b squared plus 4b plus 3b would be plus 7b and then plus 3. Right? So it is correct. Then, now that I've factored, I have a product equal to 0. I'm going to use the zero product property. The only way this product will be equal to 0 is if the first factor is 0, 4b plus 3, or if this second factor, b plus 1, is 0. And then I solve each of these separately and check your solutions again. If you're doing everything perfectly correctly and you realize that, the solutions should be good. I would still check them though if I were you. All right, so b equals negative 3/4, right? I would subtract 3, divide by 4. Or here is just subtracting 1, b equals negative 1. And again, don't forget to check. I'll put a check mark next to remind you, check your solutions back in the original, but they will both work. Okay. All right. Same steps every time. All right, so this time, got example 3, 4m, let's get rid of the under pages here, 4m squared equals 7m minus 15. Now I personally like having a positive coefficient on my highest powered term, so that's why I'm going to keep the 4m squared on the left and take all the other terms to the left as well. So we have 4m squared and then minus 17m plus 15 equals 0. Right, so I got a simplified polynomial on one side, 0 on the other. And then we're going to try factoring this thing. Now there's no greatest common factor. Let me see, if I take 4 times 15 is 60. And then the factors of 60 that add up to 17 are 12 and 5, right? So I would need, I'm just going to write the final factors. You can do the grouping. 4m here, minus 3 over here, minus 3. That'll give me minus 12m. And then 1m here, minus 5 here for minus 5m, right? So you got 4m squared minus 12m minus 5m making minus 17m, and then negative times negative positive 15. All right, so 4m minus 5 times m minus 3 equals 0. And I have what I want, right? I have a product equal to 0, and then by that 0 product property, either the factor 4m minus 5 equals 0, or the factor m minus 3 equals 0. And you solve each of these. So one solution to this equation would be positive 5/4, right? I would add 5 divided by 4 there. Another solution would be just m equals 3. And again, don't forget to check your solutions. I'll put a check mark to remind you. All right. Number 4. Same deal. It's n squared equals 5n minus 6. I personally like having a positive coefficient on the highest powered term, so I'm going to take everything to the left side. So we have n squared minus 5n plus 6 equals 0. All right, so a simplified polynomial on one side, 0 on the other. Factor. This would factor to n minus 3 times n minus 2. Again, I'm not going to go into all the details. You should know how to factor polynomials by this point. And I have now a product equal to 0. By that 0 product property, the only way a product is equal to 0 is if one of the factors is 0, at least one of the factors. So either n minus 3 equals 0, or the other factor, n minus 2 equals 0, and then you solve each of these for your solution. So either n equals 3 or n equals 2, and both of these would work. Alright, don't forget to check. Alright, I'll just do 3 real quick for you. That'd be 9 equals 15 minus 6. That's true. I mean, I could do 2 real quick too. 4 equals 10 minus 6. That also works. Both of them work. And you should be checking. Alright, number 5. Now, one thing I'm noticing from number 5, you have 7a squared plus 14a equals 7a. One thing I noticed from number 5 is that, all the coefficients are multiples of 7. But I'll deal with that in a second. So like I said in the beginning, I want to take everything to one side, 0 on the other. So I'll keep the 7a squared, and then 14a minus 7a would be positive 7a. Alright. And then since this is an equation, you can multiply or divide both sides by the same number and it'll still be the same equation. So I notice, like I said, these coefficients here are both 7. So what I'm going to do is I'm going to divide by 7 on both sides. Right. So that'll give me a squared plus a, and then 0 divided by any non-zero number is 0. So I just divided by 7 on both sides just because I noticed, right? Just because I noticed that all the coefficients had a common factor of 7. All right, and dividing by 7 will just make the numbers smaller and easier to work with. All right, and now that I have my polynomial on one side, 0 on the other, we factor. Now this is a simple binomial, right? So first I look for the greatest common factor. They both have a common factor of a. Right? So I'll pull a out. And when I remove a, the remaining factor would be a plus 1. And that's it, right? It is factored. And then I have a product equal to 0. And applying that 0 product property, right, the only way a product is equal to 0 is if one of the factors, these two factors, is 0. So either a equals 0 or a plus 1 equals 0. And solving these, I get a equals 0 or a equals negative 1. And again, don't forget to check back in the original statement that both those work when you replace them with a. Alright, number 6. Same thing, I want to get everything to one side, 0 on the other, right? A simplified polynomial on one side, 0 on the other. So that would just involve adding 9b. So I'd have 12b squared, and then negative 15b plus 9b would be minus 6b. And then I have 0 on the other side, right? Equals 0. And just as in example 5, you can keep it the way it is, but I'm noticing that each of these coefficients is a multiple of 6. So what I'm going to do is just divide both sides by 6. All right, I'm going to divide both sides by 6. That'll make this 2b squared minus 1b equals 0. Right. So now I have 2b squared minus b equals 0, polynomial on one side, 0 on the other. Then we factor the polynomial. They both have a common factor of just b. Right, so I pull b out, and what's left over would be 2b minus 1, and there you go, it's totally factored. And then now I have what I want. I have a product equal to 0. And by that 0 product property, right, the only way this is going to be equal to 0 is if either factor is 0. So either b equals 0, so there's one solution, or 2b minus 1 equals 0. And solving this, we would add 1 divided by 2, b equals 1/2. And there's another solution. Again, don't forget to check your solutions back in the original. They should both work, though, if you did everything properly. Okay. Example 7. Doing the same steps. every time. So again, I would like to get everything to one side, 0 on the other. So I have 49m squared minus 144 equals 0. Right? A simplified polynomial on one side, 0 on the other. Now, this is a difference of squares, right? There are two terms, right? Remember, two-term polynomials can only be factored. One if there's a greatest common factor, which these don't have. Two if they're a difference of squares. Three if they're a sum of cubes, or four if they're a difference of cubes. And that's really it. Right? This happens to be a difference of squares, right? This 49m squared, that's 7m to the second. 144, that's 12 to the second. So what I have here is a difference. I'll just put diff, a difference of squares. And again, I'm not going to write out the details, the formula, but you should know how to factor a difference of squares. This is going to factor to 7m minus 12 times 7m plus 12. And now I have my product equal to 0. Right, and then I apply the 0 product property. So either 7m minus 12 equals 0, or the other factor, 7m plus 12 equals 0. Well, if 7m minus 12 equals 0, then m must be positive 12 sevenths. Right, add 12, divide by 7. Or, if 7m plus 12 is 0, subtract 12 divided by 7, m would be negative 12 sevenths. And there are your two solutions. Again, don't forget to check them back in the original statement. Replace m with 12 sevenths or negative 12 sevenths, and both will make the equation true. Now, since both of these are the same thing, just different signs, right? One's positive, one negative, you could also say that m equals plus or minus 12 sevenths. Right? This means the same thing. One positive 12 sevenths, one negative 12 sevenths. But either way, you have two solutions. Okay, here, again, now this is the same thing as x. I like having all this stuff. I like having stuff on the left side. All right. These are the same equation. Okay, just switch sides. That's all. And then I subtract 625. Right? X squared minus 625 equals 0. I get everything to one side, 0 to the other side. And this is another difference of squares. This is x squared minus 625 is 25 squared. 25 times 25 is 625. So I have a difference of squares. And that would factor then to x minus 25 times x plus 25. And we have now we have what we want. We have our product equal to 0. And then applying the 0 product property, either the first factor, x minus 25 equals 0, or the second factor, x plus 25 equals 0. And solving each of these, gives us our solution. So either x equals 25 or x equals negative 25. And again, you should be checking these back in the original statement. And they both work. And just as in the previous example, or just as in example 7, both solutions are the same number, just opposites, right? One's positive, one's negative. So you can actually, if you want to, write x equals plus or minus 25, right? Positive or negative. This has the same meaning as saying x equals 25 or x equals negative 25, but both are good solutions. All right, let's keep going. Example 9. Same setup, all right? Doing the same stuff. I'm going to subtract 81 to get everything to one side, 0 on the other. Again, I have a difference of squares. This is 4y times 4y. This is 9 times 9. So this will factor to 4y minus 9 times 4y plus 9, right? Or 4y plus 9 times 4y minus 9, right? It doesn't matter what order you put the factors in. And now I have what I wish, right? I have a product equal to 0. And so applying the 0 product property, either 4y minus 9 equals 0, or 4y plus 9 equals 0. Solving each of these gives me one solution of positive 9/4 and the other solution of negative 9/4. And again, please don't forget to check these. And as in the previous couple examples, you could also just write plus or minus 9/4. Same thing. All right, number 10. Same stuff. Right? I'm going to subtract 225. Right, we have 64p squared minus 225 equals 0. Right? I always want this to start. A simplified polynomial equals 0. Then yet again, I have a difference of squares. This is 8p times 8p, and 225 is 15 squared. So this will factor to 8p minus 15 times 8p plus 15. And there we have our product equal to 0. All right, and then we apply the 0 product property. The only way this product is going to be equal to 0 is if either the first factor equals 0 or the second factor, right, 8p plus 15 equals 0. And solving each of these gives us our solutions. And again, you should be checking these numbers back in the original. But one solution is positive 15/8. The other solution is negative 15/8. Again, I'll put a little check mark, remind you to check those solutions back in the original. And just as in the previous 3 examples, you could also just write p equals plus or minus 15/8. Okay, moving right along. Example 11. Same thing. I'm going to take away 36 from both sides. So I have 121n squared minus 36 equals 0. Right. Simplified polynomial on one side, 0 on the other. Now we factor. And once again, I have a difference of squares. This is 11n times 11n, and this is 6 times 6. So this will factor to 11n minus 6 times 11n plus 6. And now I have what I wish, right? I have a product equal to 0. So through the use of the 0 product property, we can now state that, the only way this is going to be true is if either the first factor, 11n minus 6, is equal to 0, or the second factor, right, 11n plus 6, is equal to 0. And we solve both of these. So we get our solutions. N can either be positive 6/11ths, or n can be negative 6/11ths, right? But our two solutions are these two numbers. And again, don't forget to check them. So positive 6/11ths, negative 6/11ths, both work. Or you could also write, plus or minus 6/11ths. All right, now example 12 is the last of these examples where you're going to have a difference of squares that I'm going over here. We have 100y squared equals 9. Again, I want everything on one side, so let's keep the 100y squared here on the left, subtract 9, and then we have equals 0. All right, I got my simplified polynomial on one side, 0 on the other. And yet again, we have a difference of squares. This is 10y times 10y, and 9 is 3 times 3. So this will factor to 10y minus 3 times 10y plus 3. And this is equal to 0, right? So we have what we want. A product equal to 0. And the only way a product is equal to 0 is if one of the factors is 0. Right? So either 10y minus 3 equals 0, or 10y plus 3 equals 0. Solving each of these gives me my solutions. Y equals positive 3/10. Right? Add 3, divide by 10. Or y equals negative 3/10. And check them both, they'll both work. Check them both back in the original statement. They make it true. And once again, you could say plus or minus 3/10 if you wanted. Mean the same thing. All right. Next example. Now we're getting into some examples that I find people have a harder time with. Here I have in 13, x plus 6 times x minus 3 equals negative 8. So notice that this number over on this side is not 0. It's negative 8. So you can't use the zero product property here. A very common mistake I will see for problems like this is people will say, oh, there's a product over here. I remember what to do. You take this factor, set it equal to negative 8, and this factor, set it equal to negative 8. Well, let's see what happens. So here's a mistake. All right, here's a mistake. This is wrong. This is bad. Let's just take x plus 6 and set it equal to negative 8 there, and then take x minus 3 and also set that negative 8 and solve. We get x equals negative 14 or x equals negative 5. But if you were to check these, look what happens. If x is negative 14, well, negative 14 plus 6 is negative 8. Negative 14 minus 3 is negative 17. Is negative 8 times negative 17 equal to negative 8? No, it's not. Negative 8 times negative 17 would be a positive 136, not negative 8. So that is not a good solution. Same thing for negative 5. We lucked out here. Negative 5 works. Negative 5 minus 3 is negative 8. Negative 5 plus 6 is 1. 1 times negative 8 is negative 8. This is good, but notice that we get a solution that's not a solution. Don't do this. Okay, don't do this. We lucked out that a solution came from this, but there should be two solutions. And you can't do that splitting up of factors like in examples 1 through 12. You can't just split the factors up with negative 8. The number on the other side has to be 0 to be able to use that zero product property, to be able to split up the equation into two equations with the factors. So that first step, right, that I am using to solve all these is to get everything to one side, 0 on the other. Remember I said I wanted a simplified polynomial on one side, no parentheses, combine like terms, right? Get everything to one side. So what I'm going to do here is I'm going to multiply this out. We're going to simplify this. This is FOIL. We got x squared, then minus 3x plus 6x, that'd be plus 3x, then minus 18, right, equals negative 8. And then I add 8. All right, we add 8, get everything to one side, 0 on the other. I want 0 on the other side. Plus 8 would be to make this minus 10. This is what I want. I want 0 on the other side when I'm trying to solve by factoring. And now I factor. Right? I get a simplified polynomial on one side, 0 on the other, and then we factor that simplified polynomial. Now this would factor to x plus 5 times x minus 2, and then we still have the equal 0. Now we can use that 0 product property. There's a reason the word 0 is in that name. I said product. 0 product property. when a product equals 0, we can split up like that. Either x plus 5 equals 0, or x minus 2 equals 0. And solving each of these, the first one here we get negative 5, which I luckily got earlier. That was a fluke, all right? Or x equals 2, and then check them. All right, now I'm actually going to check these this time. Negative 5. Now we saw negative 5 works, right? Negative 5 plus 6 is 1. Negative 5 minus 3 is negative 8. 1 times negative 8 is negative 8. That works. And see, when x is 2, 2 plus 6 is 8. 2 minus 3 is negative 1. 8 times negative 1 is negative 8. That also works. All right, so we got the second solution out of this. But yeah, please don't just split up factors just because you see a product. All right, it's got to be a product equal to 0 in order to use that. So same thing for 14, right? See, I've got a product equal to a number, so I can split them up. No, you can't. All right. I want everything on one side, 0 on the other side. So I'm going to simplify this. So we got p squared minus 2p minus 15 equals negative 7. And then I'll add 7, and then I'll have what I want. P squared minus 2p minus 8 equals 0. Right. Take everything to one side, 0 on the other, get a nice simplified polynomial, and then factor. This p squared minus 2p minus 8 would factor to p minus 4 times p plus 2. And then we can apply the 0 product property. So either p minus 4 equals 0, or p plus 2 equals 0, and solve each of these. So p is equal to positive 4, or p is equal to negative 2, and then check them. Don't forget to check them. If p were 4, you'd have negative 1 times 7 equals negative 7. That's true. If p were negative 2, you'd have negative 7 times 1 equals negative 7. That's also true. All right, I'm going to stop checking them out loud. I'm just going to tell you to make sure you're checking solutions from here on out. Okay. So very similar. Next example. Example 15. Same deal. I've got a product on one side. I can split them up. No, you can't. Only if the product is equal to 0. That is not 0. That is negative 4x. So I got to simplify. I got to take everything to one side. So first I multiply these. That'd be 2x squared. Then minus 6x plus 1x. So minus 5x. And then minus 3, right, equals negative 4x. And then I add 4x. Right, so we have 2x squared. And then negative 5x plus 4x will make minus 1x. And you got minus 3 equals 0. Now I have what I want. Polynomial simplified equals 0. And then we factor. And again, you can do this factoring with that AC method by grouping. I'm just going to jump to the end here. We'll have 2x and x, and I would have a minus 3 here and a plus 1 there. Right? And you can double check that by foiling. 2x minus 3 times x plus 1 would be 2x squared minus x minus 3. And now I have what I wish for, right? I have a product equal to 0. Use the 0 product property, either 2x minus 3 equals 0, or the other factor, x plus 1 equals 0, and solving these and checking them, we'll see our two solutions. So x equals positive 3 halves, or x equals negative 1. And don't forget to check those back in the original statement. I'll do negative 1 real quick. If x were negative 1, this first factor would be negative 1. The second factor would be negative 4. So you'd have positive 4 on the left, and negative 4 times negative 1, you have positive 4 on the right. It works. And I'll leave you to check 3 halves if you want. Alright, same thing for 16. Right? Oh man, I got a product. I can split them up. No, you can't. Right? You can only do it when there's a product equal to 0. This is not 0. Right? It is 4y. So I need to simplify things and take everything to one side first. So multiplying these two, I get y squared minus y minus 6 after foiling, and equals 4y. Then to get 0 here, I would subtract 4y. So we'd have y squared minus 5y minus 6 equals 0. And now that I have everything on one side, 0 on the other, I will factor. Y squared minus 5y minus 6 would factor to y minus 6 times y plus 1. And again, this is equal to 0. And I have what I wish for, right? A product equal to 0. The only way a product is going to be equal to 0 is if either factor is 0. So either y minus 6 equals 0 or y plus 1 equals 0. And the solutions are 6 and negative 1. And don't forget to check. 6 and negative 1. Okay, 17 and 18 are very similar to what I just saw in 16 and 15. So again, a product is not equal to 0, so I can't do anything with this just yet. So I have to simplify. Right, multiply this side out. We have 3x squared, and then plus 12x minus 2x would be plus 10x, then minus 8 equals 12x. Then to get 0 on its own side here, I would subtract 12x. That makes that minus 2x, right? So I got 3x squared minus 2x minus 8. And then this is you could factor this using the AC method or grouping, but I'll have 3x in one factor, x in the other. And I need a, let's see, minus 2 here for minus 6x, and plus 4 here for plus 4x to give me a minus 2x. Alright, so that factors to 3x plus 4 times x minus 2. And now I have what I want, right? A product equal to 0. And using the 0 product property, right? Either factor could be 0, so either 3x plus 4 equals 0, or x minus 2 equals 0. Solving gives me negative 4/3 or positive 2. And don't forget, right? Don't forget to check those solutions, and they should work. Okay. Kind of the same thing for number 18. I got a product, but it's not equal to 0, so I can't do anything with this just yet. So I got to simplify things and then take everything to one side. So this is 6y squared, then minus 2y minus 9y, so minus 11y, then plus 3 equals 8y. Then I would subtract 8y, give me negative 19y. So I got the 6y squared plus the 3, and then that's equal to 0. Now I have 0 on the other side. Great. And now I'll simplify, factor this simplified polynomial. And again, you can do guessing and checking. You can do that AC method. I see it's going to be 6y here, minus 3 there for negative 18y. Then plus 1, minus 1 here, minus 1 here, and positive y here for the minus 1y. So that's minus 18y with the outers, minus 1y with the inners, giving me minus 19y. I got the plus 3, 6y squared. So that factors to 6y minus 1 times y minus 3. And then I use the 0 product property. This is product equal to 0 here only when 6y minus 1 equals 0, or when y minus 3 equals 0. And then solving these, add 1 divided by 6, we get y equals 1/6 is a solution. Over here just adding 3, right, y equals 3 is another solution. And don't forget to check them back in the original equation. Okay. Example 19. Nothing changing. I want to take everything to one side, 0 on the other. So I would add 45. So we have 20x squared minus 60x plus 45 equals 0. Now something I'm noticing is that all the coefficients are a multiple of 5, so what I'm going to do is I'm just going to divide both sides. It's an equation. I'm going to divide both sides by 5, and that'll give me 4x squared minus 12x plus 9 equals 0. Alright, then when you factor this polynomial, it would end up being 2x minus 3 squared. Right? It would be 2x minus 3 times 2x minus 3. It's what they call a perfect square trinomial. And I have what I want. I have a product, right? 2x minus 3 times 2x minus 3, right? But you don't want to write that. Just write 2x minus 3 squared equals 0. And, there's only one factor, right? Yeah, there's two factors, but it's the same factor twice, right? It's 2x minus 3 twice. So the only way this is going to be equal to 0 is if 2x minus 3 equals 0. Alright, and there's no need to write it twice. And then you solve x equals 3 halves. And that's the only solution to this equation. Right, x equals 3 halves, and that's it. And don't forget to check it. And sometimes they would call this a repeated solution, because there were two factors of 2x minus 3, right? This would solve two equations, make two factors equal 0, so they might call this a repeated solution in some texts, or a repeated root. The number of factors that it made 0, right, which is 2, they would call that the multiplicity of the solution. So they would say this solution of 3 halves had a multiplicity of 2, but again, you don't really need to know that right now. I don't know why I'm saying it. I apologize. Okay. Next, same thing. I want to take everything to one side. So we got 3y squared minus 18y, and then plus 27 equals 0. And if you don't see it, fine, but I noticed that all these coefficients are some multiple of 3. So I'm going to divide by 3 on both sides, just to get rid of that, make the numbers smaller. It's an equation. Alright, so we got y squared minus 6y plus 9 equals 0. And just as in example 19, this y squared minus 6y plus 9, when you factor it, it's the same factor twice. They call this a perfect square, or a perfect square trinomial. It would be y minus 3 times y minus 3 again. So you'd have y minus 3 squared equals 0. And I have what I wish for, right? I have a product equal to 0. The only number that you can square to get 0 is 0. So y minus 3 must be 0. In other words, y must be equal to 3. And that is the only solution to this equation. And check it, right? Make sure you're checking it back in the original statement. Replace y with 3. It should be a true statement. Okay. Let's look at 21. Same kind of same steps every time, right? Same steps every time. Take everything to one side. So I got 15x squared minus 10x minus 40 equals 0. And just as in the previous couple examples, I am noticing, you could pull the factor out or just divide by it, because it's, if it's a number, right? As it is an equation, you can divide both sides by some number, and it's still the same equation. So I notice that all the coefficients are multiples of 5, so I'm going to divide by 5 on both sides. That'll give me 3x squared minus 2x minus 8 equals 0. Now this is not one of those perfect square trinomials like in the previous couple examples, but it's still factorable. And the way this would factor, let's see, I said negative 24, negative, I need negative 6 and positive 4, so minus 2 here for the negative 6x, and positive 4 here for the positive 4x. Great, and then you get the minus 8. All right. So that factors to 3x plus 4 times x minus 2, and I have what I want. I have a product equal to 0, can apply that zero product property. So either 3x plus 4 equals 0, or x minus 2 equals 0, and solving each gives me the solutions to this equation that I would also, you should check them, of course. So x is equal to negative 4/3, or x equals 2. There's your solutions, negative 4/3 and 2. Again, check them back in the original equation. This should make a true statement, both of them. All right. Same thing for 22. I'm going to add 35. Take everything to one side. So 14y squared minus 77y plus 35 equals 0. Right. Simplified polynomial on one side, 0 on the other. And then just as the previous few examples, I noticed that every single coefficient over here is a multiple of 7. So I'm going to divide both sides by 7 just to make the numbers a little smaller. So that'll give me 2y squared minus 11y plus 5 equals 0. And then factor this polynomial. All right, and this polynomial, pretty easily factorable. So you have 2y and y, and then I would need a minus 5 over here for minus 10y, and minus 1 here for minus 1y to make the minus 11y, and then plus 5 with the negative 5 times negative 1. Cool. Alright, so this factors to 2y minus 1 times y minus 5. Now I have a product equal to 0. Apply the zero product property. This is only true if 2y minus 1 equals 0, or if the other factor, y minus 5 equals 0. Solving both, y equals 1/2, positive 1/2, or y equals positive 5. And make sure you're checking both solutions, right? And they should both work if you did everything correctly. Alright, so it's a couple more like this. And then we get into some polynomial equations with degree higher than 2. Right? These have all had degree 2 or been quadratic equations so far. Alright, same deal. Get everything to one side. So I have 18x squared, and then plus 21x, right? I want to put the x term next. Plus 21x, and then minus 9 equals 0. Then I'm noticing that all these coefficients are multiples of 3. So I'm going to divide everything by 3. That'll give me 6x squared plus 7x minus 3 equals 0. And then factor this. Alright, so if I do that AC method, got negative 18. Factors of negative 18 that add up to 7 would be 9 and negative 2. Alright, so I need a 3x here, 2x there, and plus 3 here for the 9x when I multiply the outers, and then minus 1 here. 9x minus 2x, 7x. Fantastic. Alright, now I've got a product equal to 0. 3x minus 1 times 2x plus 3 equals 0. That's only going to be true if 3x minus 1 is 0, or the other factor, 2x plus 3 equals 0. And solving both, I get x equals positive 1/3, or negative 3/2. And check them both, right? And again, I'll leave that to you. But you should check both. Back in the original equation, replace x with these numbers. It should make it a true statement. Alright, 24, same deal. Take everything to one side. I mean, I'm laughing here because like every single one's been the same, right? I want to get a simplified polynomial on one side and 0 on the other to start. So I got 16y squared, then plus 32y. Alright, plus 32y, and then plus 12 equals 0. And then once again, I'm noticing a common factor here. Each of these coefficients is a common factor of 4. So I'm going to divide both sides by 4. That'll give me 4y squared plus 8y plus 3 equals 0. And then I can factor this, and this would be pretty easy to factor as well. Alright, 12, I need 6 and 2. 6 and 2, so I need 2y in one of these, 2y in the other, and then plus 3 plus 1. Right, this factors to 2y plus 1 times 2y plus 3, and you can check by foiling. Equals 0. Alright, I have exactly what I want, a product equal to 0. Applying the zero product property, either 2y plus 1 equals 0, or the other factor, 2y plus 3 equals 0. And solving both of these, y equals negative 1/2, or y equals negative 3/2. And check these, check these numbers. They should both work back on the original equation. So your solution set contains negative 1/2 and negative 3/2. Alright, so far, right, in examples 1 through 24, they were quadratic equations, right? The highest power you saw was squared to the second power. Well, now we're going to get into some polynomial equations that are degree 3, right? Have a cubic equations. Highest power you see is a third power. Nothing changes. The steps I'm going through do not change. I take everything to one side, and again, I like having my highest power have a positive coefficient, so I'm going to keep the 16p cubed on the left and take everything to the left. So we have 16p cubed minus 24p squared plus 9p equals 0. Right? Take everything to one side, 0 on the other. The coefficients, don't have a common factor here. Right. So now I'm going to factor this polynomial. I notice a common factor though. The coefficients, the numbers, don't have anything in common, but they all have at least a p in common. So I factor p out, and then I'd be left with 16p squared minus 24p plus 9. And then I try factoring this quadratic polynomial. And this is one of those perfect square trinomials. This is the one of those that has the same factor twice. So I have p, and then this 16p squared minus 24p plus 9, this would factor to 4p minus 3 squared. And check it out, right? Take 4p minus 3 times 4p minus 3 again, do all the foiling and combining like terms, you're going to get 16p squared minus 24p plus 9. And this is equal to 0. And I have what I want. I have a product, but this time with 3 factors. There's p, 4p minus 3, and 4p minus 3 again, right? Because it's 4p minus 3 squared. So I have a product of 3 factors equal to 0, but it's no different, right? The zero product property will still apply. You have a product equal to 0, at least one of those factors has to be 0. So either p equals 0, right, so there's one solution, or 4p minus 3 equals 0. Or 4p minus 3 equals 0 again, but there's no need to write repeated equations. And if I solve this, p would be equal to positive 3/4. Right, so you get 2 solutions out of this. P equals 0, p equals 3/4. Check them, and again, don't forget to check them, back in the original equation. Should make the original statement true. 26, same kind of deal. I'm just going to add m to get everything to one side. We have m cubed minus 2m squared, and then plus m equals 0. All right, take everything to one side, 0 on the other. And factor. These have a common factor of m. Pull that out. What's left over would be m squared minus 2m plus 1. And this is again equal to 0. And this is another one of those perfect square trinomials. How lucky are we? So this is m times, and then m squared minus 2m plus 1 would factor to m minus 1 twice. M minus 1 times m minus 1, m minus 1 squared. And this is equal to 0, right? So I have a product equal to 0. Great, I can apply that zero product property. So either m equals 0, which is one solution, or the other factors. M minus 1 could be equal to 0, or the other factor, m minus 1, could be 0. But again, I don't need to write that twice. All right, and then solving this second equation, I get m equals positive 1, and then check those. Right, we get these two solutions. 0 is a solution, 1 is a solution. And check them. Plug them back into the original statement for m, and you should see a true statement. All right. Example 27. Another cubic equation. Doing the same stuff, right? Take everything to one side. 2x cubed, then minus 24x squared plus 72x, all on the left side here, equals 0. Now, one thing I'm noticing is, just to make the numbers smaller, I notice that all the coefficients are a multiple of 2. So I'm going to divide by 2 on both sides, just to make the numbers smaller. So we have x cubed minus 12x squared plus 36x equals 0. And now I'll factor. All right, now all three of these have x in common, so I factor x out. What I'm left with is x squared minus 12x plus 36, and yet again, goodness gracious, this is another perfect square trinomial. We have x times, and then x squared minus 12x plus 36 factors to x minus 6 squared. It's x minus 6 times x minus 6. All right, this doesn't always happen. I don't know why. The previous three examples, this doesn't always happen. Things aren't always perfect square trinomials. Right? I hope you understand that. All right, then we apply the zero product property, right? Because I got a product of three factors here, x, x minus 6, and x minus 6 again, equal to 0. So either x equals 0, so that gives us a solution that's solved for, or x minus 6 equals 0, or x minus 6 equals 0 again, but like I did in the previous two examples, you don't need to write a repeat equation. Solving that gives me x equals 6, positive 6, and then check them. 0 would work, 6 would work. Go back to the original statement and make sure it's a true statement. All right, number 28. Another cubic, same deal. Get everything to one side. I got 3y cubed, then minus 24y squared plus 48y equals 0. And then just as in the previous example, to make the numbers smaller, I noticed that every single one of these coefficients is a multiple of 3. So just to make the numbers smaller, I'm going to divide both sides by 3. That'll give me y cubed minus 8y squared plus 24y. Nope, not 24y. 16y. 3 times 16 is 48. Equals 0. All right, now we factor. Right, now that the coefficients are as small as I can get them, now let's factor. Again, all three of these have a y in common, so I factor a y out, and you'd be left with y squared minus 8y plus 16, and oh my goodness, another perfect square trinomial. Man, again, this isn't always going to happen. So we have y times, and then y squared minus 8y plus 16. That's y minus 4 squared. Y minus 4 times y minus 4. And this is a product equal to 0. So either y is equal to 0, so there's a solution, or y minus 4 equals 0, giving me y equals positive 4. And check again, these are the only two solutions to this. So check, 0 for y, 4 for y should make the original statement a true statement. All right, now finally to the last page, got exercises, examples, 29 and 30 here. These are the last two. All right, so same steps every single time. I'm going to take everything to one side. So here we got 36x cubed plus 24x squared, and then plus 4x, right, equals 0. And then just like in the last couple examples, I noticed that all the numbers, all the coefficients are multiples of 4. So just to make the numbers a little smaller, I'm going to divide both sides by 4. So that'll give me 9x cubed plus 6x squared plus x equals 0. Now that I have the coefficients as small as I want them, I'm going to factor. All three terms have a factor of x, so I pull that out. We have 9x squared plus 6x plus 1. And then we have x times, and man, another perfect square trinomial. 9x squared plus 6x plus 1 factors to 3x plus 1 squared. It's 3x plus 1 times 3x plus 1. Alright, and again we have a product equal to 0. The only way this product is going to be equal to 0 is if either factor 0, so either x equals 0, so there's a solution, or 3x plus 1 equals 0, or 3x plus 1 equals 0. But again, I don't need to repeat equations. And that gives me x equals negative 1/3, right, subtracting 1 dividing by 3. And don't forget to check your solutions back in the original statement. Should make both of those numbers 0 or negative 1/3 should make the original statement a true statement. Alright, now finally, example 30. Same steps, every single time. Take everything to one side. We got 2y cubed plus 2y squared minus 12y equals 0. I notice that all the numbers, all the coefficients are a multiple of 2. So just to make the numbers as small as I want, as small as possible, I'm going to divide everything by 2. So we get y cubed plus y squared minus 6y equals 0. And now that the coefficients are all as small as possible, I will factor. They all have a y in common. When I factor y out, I'll be left with y squared plus y minus 6. And finally, here's a trinomial that's not a perfect square. All right. We have y and then times y squared plus y minus 6 would factor to y plus 3 times y minus 2. And we have this product equal to 0. And it's a product of three factors again, y plus 3, and y minus 2. And whenever a product is equal to 0, one of those factors has to be 0. So either y equals 0, that's already solved for, so there's a solution, or y plus 3 equals 0. Solving that for y gives me negative 3 for y. There's another solution. Or the last factor, y minus 2 equals 0, giving me y equals positive 2, adding 2 to both sides. And don't forget to check them. But finally, we get to an equation where there are 3 solutions. 0 for y, negative 3 plug in for y's, you'll get a true statement, and positive 2 if you plugged in, you get a true statement as well. Great. So every single one of those, right? Solving a polynomial equation. You get a simplified polynomial on one side, 0 on the other. You factor that polynomial as much as possible, and then use the zero product property to find your solutions. And of course, check your solutions back in the original equation. Alright, so I'm hoping that watching me go over these, 30 examples help you out when you're working on similar problems. And thank you very much for watching.